Hello everyone, this is Praveen Kumar and welcome back to the Hellers Classes channel. Up to the previous videos, I explained you about the properties of cement and what are the categories of cement and types and what are the tests to be conducted on cement and completely about the cement. I think I have been covered of maximum, and similarly some objective type of questions which are asked in few competitive exams like GATE or IES. Those things all been discussed. So today I'm going to proceed with aggregates. Aggregates are the important constituents in concrete. Actually, they give the body to the concrete and reduce somewhat shrinkage and as well as economy also. So without using 100% of cement to reduce the economy, we can able to use some of the aggregates, or simply we can say these are the rocks. Before that, we consider that the aggregates should be a chemically inert material, but it has been recognized that some of the aggregates are chemically active. So for that, before going to select any aggregate, we need to select an chemically inert materials. So under these aggregates, in this video we are going to discuss about a classification. What are the classification of aggregates, sources, and what are the different sources for getting the aggregates, and as well as size. So in different kinds of what kind of sizes that actually they are available. And next one is the shape, in what type of shape that particular aggregates are available in the market and what kind of shape is useful for us, as well as texture, what kind of textures that actually we need to choose for this structure, and strength, specific gravity and bulk density, moisture content, bulking factor, cleanliness, soundness, chemical properties, thermal properties, durability, sieve analysis and grading. So these things actually we are going to discuss in this particular video about the aggregates. So based upon this, we may get a basic idea about the aggregates, that what kind of aggregates are being used for the structure and what are the aggregates which are not suitable for the structure. So these things we may get a basic idea about the aggregates, that it may be helpful for the selection of the aggregates. So now we are proceeding for the first one, which is the classification. Aggregates are generally based upon their weight. It may be classified into three categories: a normal weight, lightweight aggregates, or heavyweight aggregates. Based upon the purpose that we are using, we can choose any one. For lightweight structures, we are proceeding for lightweight aggregates. For normal structures, we are using the normal weight aggregates. For heavy thing only, we are proceeding for third one. Based upon the formation, these are the naturally formed as well as artificially formed aggregates that actually available in the nature and even in the market also. Sand, gravel, crushed brick, granite, quartz, basalt, sandstone, and everything is a naturally formed stones. Artificial stones are broken bricks, air cooled slag, sintered fly ash, and bloated clay. These are the artificially formed aggregates. These are also may be used for the structure where the natural resources are not available to bring back or to make the concrete in a ready manner. So this is about the classification. So next one is the source. Generally for any type of structures, we may have only three kind of sources, that is based upon their classification of rocks. First one is the igneous rock, which is the strongest rock that ever which is available for us, especially granite, basalt, dolerite. These are the one of the kind. Sedimentary rocks, these are the secondary rocks which are exposed to atmospheric conditions. Somewhat the strength is less when compared with the igneous rocks. So these are the secondary rocks which may form from igneous rocks or metamorphic type of rocks. So the third category is metamorphic rocks. The name itself indicates a metamorphism which may be exposed to high pressure or high temperature. So that's why the strength of rock somewhat more when compared with the sedimentary rocks. Even quartzite or somewhat a high strength rocks are available here. Even the specific gravity is also more. So next classification, next one thing is size. So basically we have different sizes that actually we may have. So that size may differ with the thickness, spacing of reinforcement, clear cover, mixing, handling and placing techniques. Based upon the size only, these parameters will change. Even based upon more size particle, then we need to proceed for more. So the sizes, basically we have only two categories, coarser and finer. The particle size which may be greater than or equals to 4.75, that is coarser aggregate. Less than 4.75 mm, we generally consider these aggregates are fine aggregates. One of the basic example is sand. Sand is a fine aggregate in general. The granite rocks, whatever the coarser particles we are using for the concrete making, so these are generally to be considered as coarser aggregates. Next one is shape. The shape of the aggregates is also one of the important characteristic which may be differ for the workability property. Based upon the shape also the workability will be differed. While coming to here the tabular form, in general we have rounded, irregular, or platy round, angular and flaky, and these are the descriptions are been given for each classification, and some of the examples are also been displayed here and from where it is actually available. So in this figure you can get a basic idea that how the shapes are been there: rounded shape, flaky and crushed concrete aggregates. A rounded shape is not preferable and flaky is also not possible to make a good concrete, and only the thing is crushed aggregates. And even in this figure also you may get a basic idea about how the rocks are to be visible: rounded, irregular and angular. So basically we are using the angular aggregates only to make a good strengthened or good probable making of concrete, and this is only the possibility to choose the angular only. The angular aggregates are generally we are using, not the flaky or very thickened materials or rounded materials. So next one is texture. So basically texture is also one of the basic component. If the texture is very smooth, then we are not going to able to get a good strength for that. If the texture is somewhat rough, we may get somewhat a flexure of more. If the smoothness is more, we may get a compressive strength of more. Even for rough aggregates we require more water cement ratio also. So that water cement ratio we'll discuss in the previous or in the next videos. And what is that water cement ratio, and those things will be discussed in concrete properties. So if there is a smoothened surface aggregates are there, then the compressive strength will be more or flexure will be less. So based upon this will be varied. So next one, surface characteristic of aggregate. In general, if the texture is glassy, this example has been given even for smooth, granular, crystalline and honeycomb type of or porous nature. There are few examples have been given. So next one is strength. Based upon the aggregate strength only, we are going to describe what kind of structure that it is suitable. So in general, for producing of high strength or ultra high strength concrete, and when competing to use aggregates manufactured from weathered rock or aggregate manufactured by industries, based upon this the strength is also going to vary. That thing will be discussed in the next testing properties. So aggregate crushing value, which means it is to be tested in 25 mm diameter, 25 mm height of cylindrical portion, which is of exposure to compressive stress, and based upon while applying some amount of force 45 megapascals to a maximum of 545 megapascals, we may get the crushing value also, and this is also been discussed in the testing part. We will discuss aggregate abrasion. So surface abrasion is also one of the property of aggregate which may impact the property or strength of the aggregate, and these things will be calculated or tested based upon dual iteration test and door iteration test, Los Angeles separation test. And it is also more important one, modulus of elasticity, as well as this has been discussed in front of materials. Modulus of elasticity, as like the materials, it affects both shrinkage, elastic behavior, as well as very small extent of creep of concrete. I think that creep value we may get in concrete. Bulk density of the aggregates gave vulnerable information about the shape grinding of the aggregates, and this bulk density value is also calculated in our laboratory by calculating specific gravity of the aggregates minus bulk density in kgs per liter divided by specific gravity of aggregates multiplied by 100. This is the percentage of voids. The specific gravity of aggregates will be calculated in the laboratory, that we can easily get it, the bulk density as well as specific gravity and everything. So next one is the specific gravity. In concrete technology, specific gravity of the aggregates is made using in design calculation, especially for concrete mixes. Whenever if we want to design a concrete, definitely we need to get a basic idea about specific gravity of aggregates, then only we can design it. And this specific gravity, how we can able to calculate, and these things will be continued in the testing of aggregates. Next one is absorption and moisture content. If the aggregates absorb the maximum amount of water, then it is having a little bit amount or maximum amount of porous nature in it. So if the porous nature is more, then definitely the strength of the aggregates is definitely will be reduced. If it is reduced, the concrete strength is also somewhat affected. So the allowable percentage of voids are approximately from 0.5 to 1% of the complete weight of aggregates only. So if it is exceeding the value, then we won't choose such kind of aggregates for the construction. Next one, bulking of aggregates, which means swelling. Especially this kind of nature we can observe in fine aggregates like sand, and that particular water is going to form like a layered which is over the surface of fine aggregates. So because of that, the volume of sand will be somewhat increased, so there is a bulking of sand or bulking of aggregates. So majorly in fine aggregates that we can get in it. So next one is measurement of moisture content of aggregates. That measurement of moisture content of aggregate in the field must be very quick. It is the most important thing that we need to know before going to design a concrete or choosing an aggregate. The most popular one is the drying method. So in this, by using the oven and weighing machine, we can easily identify, and in experimental procedures of the next video we will continue with that. Next one is displacement method, which by using siphon can method we can easily identify. So next one is calcium carbonate method, and it is also one of the most accurate method for easily identifying the moisture content, and electrical meter method, and in this method also we can easily identify an automatic measurement. So next one is cleanliness. So before going to choose the aggregates, we need to know whether the aggregates are cleaned of clay or loose materials over the surface. Without that, we won't choose that aggregate as a better one. So next one is soundness. If the sound which we may get whenever the two aggregates are collide each other, if they are exhibiting a maximum amount of sound which may result, and it represent as voids are to be more, so the sound should be of very low for high strength aggregates. Next one is the most popular thing that we need to discuss is the alkali aggregate reaction. Before going to choose any kind of aggregates, we need to select the aggregates are to be inert, and it won't react with the cement. Especially cement contains some amount of alkalis. If that alkalis are going to react with the aggregates, and if that aggregate is reacts with the alkali kind of materials existed in cement, definitely there may be some amount of reacted particles will form, and that from that portion there is a weak portions are being formed, and because of that the strength of concrete will be slowly reduces because of that alkali aggregate reaction. And while coming to the factors which are promoting the alkali aggregate reaction is reactive type of aggregate, high alkali content in cement, availability of moisture, as well as optimum moisture conditions. If based upon these factors, the alkali aggregate reaction will be somewhat more. And if I want to control that alkali aggregate reaction, so then I have to select a non-reactive aggregate, or by use of low alkali cement, or by use of corrective moisture such as pozzolanas, and that is also one of the alternate method, or by controlling the void space in concrete. So that is also one of the better one to control alkali aggregate reaction, or by controlling moisture condition and temperature also we can able to reduce the alkali aggregate reaction. So these are the basic things how we can able to control that alkali aggregate reaction. Otherwise, if that alkali aggregate reaction happens, slowly the strength of concrete will be reduces because of that part. So this is what about alkali aggregate reaction. So next one is thermal properties. And the thermal properties of basically depends upon the three properties, that is coefficient of expansion, specific heat, and thermal conductivity. If the coefficient of expansion is more, and if it is exposed to a low temperature also, the expansion contraction joints will be extended for more, specific heat also should be less, and thermal conductivity is also should be less. Otherwise it will absorb a maximum amount of heat, then that crack distribution is also somewhat more for any kind of structures. So next one is grading of concrete. Grading, which means it is to be varying from one size to another side, so that is the grading. So it may be of aggregates containing each and every size in it, otherwise few sizes are being missed also. And because of that, based upon the classification and entire thing, we may be classified as continuous, it may be classified as a continuous grading or gap grading also. So this will be discussed in the lateral stages. Next one is the sieve analysis. This is generally applicable for fine aggregates especially. Even for the coarse aggregates also we will proceed for the flakiness and elongation test also. Next one is the specific area and surface index. I am briefing you about specific area, which is the surface area per unit weight of the material is termed as specific area. The total surface index of the mixture of the aggregate is calculated by multiplying the percentage of material retained on it Cu by corresponding surface index, and to their sum is added to constant 330, and the result is divided by 1000. So this is how we may get that specific surface and surface index. So next one is the standard grading curve. If we want to grade any kind of materials, or either it may be a coarser aggregate or finer aggregate, based upon the curvature and sieve analysis we may get this kind of graph, and based upon this graphical representation only we may classify that whether it is belongs to what kind of zone it is, either it may be belongs to zone A or zone B or zone C. Otherwise, for especially in sieve analysis we may get these kind of graphs, and based upon these graphs we may get either it may be belongs to zone 1 or zone 2 or zone 3 or zone 4. Based upon this zoning classification only we may get that these kind of aggregates are suitable or not. The last one is the gap grading. So in the previous thing we discussed about grading, which is a continuous grading. Gap grading means we are going to miss some kind of size of materials, and then we may get a maximum voids or a minimum voids, and those voids are to be filled by the mortar, and that mortar will combine those aggregates in a proper manner. So this is about the aggregates. In the next video we will continue with testing of aggregates and what kind of tests are there. Thank you.